Okay, we're going to be getting into something called the law of sines. You probably did this in geometry, and we're just going to do a few examples like the geometry level, and then we'll crank it up a notch and some other ones. So, law of sines. First thing, if you look at this box up here, you've got law of sines. Sine A over A equals sine B over B equals sine C over C. So you only take two at a time, though. You'll never have all three of them, A, B, and C, in a row like that. So it just depends on what information you were given. And something to remember, capital letters are the angles, lowercase letters are the sides across from those angles. So let's look at a geometry type first. If you look at this example, solve the triangle, given angles A and C and side C. So when you draw out the triangle, it doesn't really matter where you put your A, B, and C to begin with. I usually just go like this. Label up the angles, 20 degrees for angle A, 25 degrees for angle C. And remember, side C should be across from angle C. So side C would be 80 over here. Okay, now it says solve the triangle. And what that means is find all the missing pieces. So in blue, I have everything that I was given. Now in red, I'm going to start up here to find angle B. You don't necessarily have to write this out, but it would be 180 degrees for the entire triangle minus the two angles that were given. So angle B should equal 135 degrees. Okay, so I have the missing angle now. That's good. So if I label that 135 up here. Okay, so now I need to find side B and side A. So when I start that work, let's set up the information that I was given. So I'd say sine of angle A, which is 20 degrees, over side A, little a, equals, and you always want to go back to the given information. So I'm going to go with sine angle C, because it was given. It's not rounded or anything, over side C, which is 80. Okay, so from here you're going to do a little cross multiplying. So my next step would look like this. 80 sine 20 equals little a sine 25. And then what you have to enter in the calculator is 80 sine 20 over sine 25. And when you do that, just be careful with those parentheses. I'm pretty sure you have to close that one after the 20 degrees. So you should get A to be approximately 64.7. And for side lengths, we're going to round to the nearest tenth like that. Okay. Now, if you do the same thing for side B, we should get side B to be about 133.9. Okay, so that example we just did would be something that you would have done in geometry. You were given two sides and an angle, and then you solve for the missing pieces. So now we're going to look at it more from a pre-calc level. You could actually have three different possibilities. You can have one solution, like the one we just did, had one solution for each angle and side. You could have two solutions, meaning there are two full triangles that meet the requirements, or you could have no solution, meaning if you tried to draw out the triangle, the sides wouldn't connect. Okay? Now, the time to look for these kind of weird things to happen is when you're given what we call the angle side-side case. So if you think about it, I'm not going to say it, but angle side-side, think about Miss O'Neill saying it maybe, or backwards of it, so it'd be side-side angle. So when you're given the angles and sides in this in this way, you have to see maybe there's two solutions, maybe there's no solution. Okay, so let's try one first where you only have one case, and then I'll explain why there's only one case and when to look for another one. Okay, so if we start drawing out this triangle, just like we did in the example before. Alright, so we have angle A, angle B, C, label in the sides and angles, 45 degrees. Little a is 7 root 2. Little b is 7. Okay, so what you have to notice here is I've been given an angle and two sides, and you read them in the way they're drawn on the triangle. So it would go angle, side, side, like that. Okay, if you think about the one we just did, that one, the original information now that we were given was an angle, angle, side. So that's not like this one. Angle, angle, side doesn't spell that bad word. But the one down here does. So what we have to be careful of, maybe there's two solutions, maybe there's no solution. But we always have the case that it could just be one solution, like a normal triangle. Okay, so let's start setting this up. if I were trying to solve for angle B, it would look like this. Sine of 45 degrees, so sine of A over side A, which is 7 root 2, equals sine of angle B, meaning we don't know the angle, over side B, 7. Then if you do a little bit of cross multiplying, here's what I get. 7 sine 45 degrees over 7 root 2 equals sine B. And then you have to remember, to undo the sine, you're going to do inverse sine. So it would look like this in the calculator. So once again, be really careful how you enter all this in. And your mode should be in degrees, because now we're back into degrees, 45 degrees. Okay, so all of this would go in your calculator. That's going to help you solve for angle B. Okay, so if you punch all that in, and for angles, we want to get used to going to the nearest whole number, we would say angle B equals 30 degrees. Okay, so that would be one piece of the missing information. Okay, now, if we wanted to see if there was another angle that worked, here's what we would do. Let me do this out to the side, kind of way out to the side here. Okay, so if I wanted to know where else could sine of angle B be the same as at 30 degrees. Okay, so now I need you to think about all the stuff we've been talking about. 30 degrees would be right here in the first quadrant. Okay, and I would say, where else would sine of 30 give me the same value? So you should think of all students take calculus, think of the fact that we could have a triangle in the second quadrant and still meet the requirements. And then think, the angle from here to here would be 150 degrees. So down here, what if I write angle B2 could also be 150 degrees? Okay, so sometimes there is that second angle that works. Now, the reason it doesn't work for this example is if you take 150 degrees that we just found plus 45, which was one of the given angles in the triangle, you end up with 195. So that's too big for a triangle. All right? So you always have to look for that second angle. But in this case, it doesn't work. So I'm going to say no to the idea that maybe there's a second triangle. Okay, so there's only one triangle for this one. And if that's the case, then you just keep going like we did in the example before and solve for the missing pieces. All right, now let's look at another example of the angle side-side where maybe it's not just one solution. Okay, so here's my triangle, drawing it out. I always draw it the same. 43 degrees for angle A. 186, a pretty big side length for side A. And side B is 249. Alright, so again, you don't have to do it every time, but this is a case where I've been given angle, side, side. Okay, so I have to pay attention when I'm doing this a little bit. Okay, so if I try to start solving, I would start solving for angle B. So I'd say sine of angle A over side A equals sine of angle B. Oops. Over side B. Okay. Now, same approach. What I'll enter in my calculator is this. Inverse sine of, after I multiply the 249 over, sine 43. Again, be careful when entering it. Give it a shot. Maybe make sure you get the same thing I do when I do this. Equals angle B. And when I do that, I get B to be approximately 66 degrees. Okay, and again, round those angles to the nearest whole number. Okay, so now let's take a little side note. Let's see if there's a possibility of having a second triangle. So the way to figure it out is, so think about this again. Alright, so 66 degrees would be in the first quadrant. The other place where it would equal the same ratio would be in the second quadrant. But the angle is going to be from here to here, so there's a possibility of a B2 being 114 degrees. Okay, so if I take my B2 of 114 and my given angle of 43, I'm not yet over 180. So that tells me I do have a second triangle possibility. Okay, and when that happens, come back here to this angle B of 66 and throw a little 1 subscript on there. So what I'm saying here is I'm going to have 2 separate triangles with all this given information. Okay, and I'll explain in class why that can happen. I'm trying to draw it out for you guys. All right, so if I have an angle B1 of 66, I can then find my C1 of, if I take 180 minus 66 minus 43, then my C1 could be 71 degrees. Okay. Then if I think of the idea, what if B is 114, and I take 180 minus 114 minus that given 43, my other possibility for angle C would be 23 degrees. So you can see I've got 2 different possibilities for angle B, 2 different possibilities for angle C, which means I should also have 2 possibilities for side C. Okay, so let's show all that work over here. Let's get one of these completely done. Okay. So if I come down here, all right, let's solve for side C now. So again, I'm always going to go back to the given information for this last step. So I'm going to give the original sine of angle A over the original side length of A, so those aren't rounded, those were given to me, equals sine of angle C1, which is 71, over side C1. Okay, so if I do that, let's round that to the nearest tenth. Side lengths typically get the nearest tenth. So let's call side C1 about 257.9. All right, now do all of that again, but this time I'm going to use angle C2. So sine 43, again, back to the given information. Don't use any of the rounded numbers whenever possible. Okay, equals sine of angle C2, so now I'm going to use the 23 degree angle, over side C2. And if I crank all that in my calculator, we should get about 106.6. Okay, so again, side length to the nearest tenth. So take a look at that example. That's pretty involved. We had to find 2 angle B's, 2 angle C's, and 2 side C's. And it was all because we started out with this bad word, the angle side case. Okay. We're going to do one more example here, number 3, and then I want you all to try number 4, and I just noticed that's not supposed to be a beta, it should just be B. Try number 4, and then I also want you to try the word problem number 5, and bring those to class with you. Okay, number 3, start drawing it out, so you don't always know what's happening right away, so I always start by just drawing out the triangle, ABC. Angle A, side length A, side length B. Alright, we should start noticing more and more when we do these. Here's another one, angle, side, side, bad word. Okay, so when that happens, we just have to be a little cautious. We always start them the same. Sine of the angle given over the opposite side. Okay, let's solve for angle B now. Sine angle B over 122. Alright, and then just like before, here's what goes in my calculator. Really carefully. Okay, that will be angle B. Now, you should notice really quickly when you do this one, you get an error on the calculator. So what we need to do before we just say no solution, because the answer to this is actually no solution, but before we do it, we just want to double check, make sure we hit everything right. So the way I usually do that is, really careful with parentheses there, I will enter in my calculator only this part to see what it looks like. So when you do that, here's what you end up getting. You end up getting a 1.166. And what you should start thinking about is the fact that sine has to be between -1 and 1. So when I get this sine of 1.166, that's too big. So that's why the calculator is telling me error. So for this triangle, we're going to say no solution, meaning if I try to put the pieces together, it doesn't actually form a triangle. Okay, so there's a no solution case. All right, so now it's up to you. Try number 4 and then give that number 5, that word problem, a try, even if you only get to the picture, and we'll go over it tomorrow.